Alrighty. So we are 5 minutes more before we start today's session. So once again, welcome everybody who is here. For those who are watching that are not live, okay, so welcome. And for this paper, please prepare to print a copy when you are working together. This will ensure the most optimal way of following. Yeah. Okay, we will begin in 5 minutes. See you later. And it's 8 p.m. So without further ado, let's begin today's session. So once again, welcome. Hello, good morning, good evening, good afternoon, good night to whoever who is joining us. I'm Zong Yang, and I will be your tutor for today for IGCSE Paper 6 for Physics. And alright, so today we'll be solving the entire paper for IGCSE Physics, subject code 0625, summer 2025, paper 6, set 1. Okay, 1 second, and great. All right, so for our session today, we'll go through the entire question paper and we'll be explaining how to solve each question in detail. And I hope everybody here will find this useful and you'll find this session meaningful, right? So for everybody who is here joining us live, please take note that we'll be answering 10 appropriate questions from the live comment section regarding the paper we are going through and any other IGCSE Physics questions on a first come, first served basis. And these questions will be vetted by our very helpful and very kind teacher, Mr. Narayan sir. So please submit your queries if you have any. So one more thing before we begin today's paper. So if you are joining us and you intend to solve this paper together with me, I would highly recommend you to print a physical copy of this paper, as most of the things in here requires scale drawing on using pen, paper, and also a pen, pencil, and paper. And most importantly, you need a ruler, and you also need a protractor, which I have somehow lost in my vicinity, but doesn't matter. It's you who need it, not me. So please prepare a ruler and a protractor and make sure you have the physical paper with you printed 1:1 scale. So actual A4 and whatnot, okay? So with that out of the way, let's begin our paper solving for today. All right, so without further ado, let's begin. Right, so I hope everybody can see the screen clearly. Let's see. Can everybody see whatever I'm doing? Okay, all good, yeah? All right, so Pikachu is here. Let's start our lesson proper. This is question paper 6-1 from May-June, which is summer 2025. Okay, so I have a comment that this paper is relatively straightforward. So if you do feel so, let us know in the comment section below, or just comment this is easy in the chat, okay? Right, so without further ado, let's begin. All right, so let's go to question 1. So where a student determines the density of a ball, right? So a student wants to determine the density, right? Density basically is rho, right? To be equals to the mass of the object divided by the volume, right? So he places the ball between two wooden blocks as seen from above in figure 1.1, and he takes two measurements, D1 and D2, as you can see over here. So in question 1a, part 1, on this figure, we are to measure the lengths D1 and D2 using our trusty ruler, okay? So for this paper, I've already done the measurements using a ruler, and I put the ruler right on my screen to measure it. And of course, it has to be 1:1 scale. So by doing so, you should be able to, and if you print this out properly on a piece of paper and it's a 1:1 scale as well, and if you print this properly, you should be able to get D1, it should be equal to 2.7 centimeters, and D2 should be equals to 2.5 centimeters, okay? So as long as you get these two values right, you should be able to get your first mark for this question, all right? So once again, please use a ruler. Please don't skim this out, okay? Yeah, and if you can, please print this whole paper on a A4 sheet, so to ensure you have proper practice. All right, so enough nagging, let's move on to part 2. Right, so using these measurements, right, we are to calculate the diameter D of the ball, and we are to show our working. So basically we have two values, 2.5 and 2.7. We are to calculate the diameter, which is the average of these two. So average diameter, oh dear, diameter equals to the sum of these two, right? 2.7 plus 2.5 divided by, we have two values of d, which is divided by 2. So doing the mathematics, we should get 7 plus 5 is 1.2, 1.2, 5.2 divided by 2, we should get 2.6 centimeters, all right? So this is what we get. So of course, if you, right, if you get the average, that is 2.6, correct, right? You should get your 1 mark here as well, okay? So now let's move on to part 3. Now 2 marks, you have easily 2 marks in the bag already. Let's move to part 3, which is 2 marks. So we are to explain why this method is used to measure the diameter of the ball. So basically, why can't you just, take a ruler like this, right, and put the ball right on top like this? Why can't we do that? Well, if you notice, right, the ruler just, if this is a ball, it sits right on top of it, right? It is very difficult to determine where the edge of the ball is on one side and where the edge of the ball is on the other side, right? So this is something that you guys know very, very well. It's something called parallax error, yeah? So simply put, right, let's write it down. It is difficult, all right, to measure the diameter of the ball, right? Okay, using a ruler directly with a ruler. Okay, as doing so, okay, will give rise to parallax errors. Okay, so as long as you write a reasonable advantage for the method in question, or if you say it's difficult to measure the diameter directly, or if it's hard to find the, if you write down, it's hard to find the center of the ball, you get your first mark. And your second mark comes if you state, right, using a ruler to measure the diameter directly will give rise to parallax errors. This is your second mark, this is your first mark, and that's how you get your full 2 marks for this question. Straightforward, yeah? Okay? As said by Mr. Naran sir, it is easy. Give me a harder one, yeah? Okay? So, let's move on to part B for question 1, okay? So, for part B, we are to calculate the volume V of the ball using this equation. V is equals to 0.52 d cubed. So, we are to include a unit as well. So, let's take a look here. V is equals to 0.52 d cubed, okay? Okay, so let's calculate. So we have calculated before, d is equals to 2.6. And 2.6 we are to cube it, okay? 2.6 cm. And let's plug this into our calculator. And by doing so, we should get this really long and convoluted number, 9.13952, yada, yada, yada. Okay, so usually in all our calculations in IGCSE Physics, right, we want our numbers, our final answer to be in two significant figures, right? Usually two significant figures. So what exactly is two significant figures, right? Basically, we take the first number. Let's take a look at it, right? Is it a 0? If it's not a 0, this is our first significant number. Then this is our second significant number. This is our third, and so on and so forth, right? Okay, so 1, 2, 3. And since we want this answer to be in two significant figures, we will lock in these two, and we'll take a look at significant number 3. Okay, now 3 is smaller than 5, right? So if the third significant number is smaller than 5, we will round down the number. And if this number, let's say is 8, it is larger than or equals to 5, we round upwards. So since this is 3, 3 is lower than 5, oops, right? We round down. And so the answer should be, we have to write this squiggly equal sign, right? This means approximately equals to, this is equals to approximately equals to 9.1. And what's the unit? Because this is volume, and we already stated that volume is cm, so the original volume d is in cm, so cm power 3 is cm cubed, right? Okay, and we have to write down two significant figures. Okay, and of course, writing like that, let's write it down nicely on the answer over here. 9.1 cm cubed. Okay, so if you write 9.1, this is your first mark, and if you write the correct unit over here, this is your second mark to get you your full 2 marks. Okay, pretty straightforward, yeah? Okay, so give me a second. Let me just put this over here. All right, so let's move on to part C. Okay, let me take a look at the over here. Right, so the student now, well, now he's done measuring the volume, right? He now measures mass of the ball, okay? Sorry, the mass of a dish, which is 102.5 grams, right? Then he put the ball on the dish, all right? And he measures the combined mass, MC, of the dish and the ball. So figure 1.2 shows the dish and the ball on the balance. So we are to record the reading shown on the balance. So the balance over here, this is very simple. This is a digital mass balance, right? So of course, whatever it says down here, we just write it down over here, right? So the combined mass over here is 114.1 grams, already given for you, okay? Fantastic. Now, we are to calculate the mass MB of the ball, and you have to show our working. So the combined mass is 104.1, and the mass of the dish is 102.5. So we just take the mass, combined mass, minus the mass of the dish to get the mass of the ball. So MB is equals to MC, which is the combination of everything, minus MD, which is the mass of the dish, now is equals to 114.1 minus 102.5, and doing this quick math, 11.6 grams. Okay, that should give you your answer of 11.6 grams for the ball. Okay, very straightforward, yeah? And last but not least, we are to calculate the density of the ball using this equation. Rho is equals to mass of ball divided by volume, and we are to give your answer to a significant suitable number of sig figs for this experiment, and you have to include the unit. All right, so let's do this. Rho is equals to mass of the ball divided by volume. Now let's take a look what we have calculated. The mass of the ball is 11.6 grams, okay? Divided by volume. The volume, as we have calculated earlier, is 9.1 centimeter cube. So, wait, hang on a minute. How many again? 9.1, okay? 9.1 centimeter cube, okay? So, doing the mathematics, all right, let's check out what this is. Plug this into the calculator. You should get 1.2747 yada 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 yada. And let's do this as per usual in two significant figures. So let's take a look here. First significant figure, second significant figure. Let's lock this down first. Let's look at the third number, 7. 7 is greater than 5. So we round 2 up. All right, so 2 becomes 3. So 1.3, okay? But What's the unit? It's not monkeys, it's not donkeys, it has to be something, right? So you see over here, grams divided by centimeter cube. So it's grams, right, per centimeter cube. Okay, this is our unit. And of course, we have to write this in two significant figures. And that is our answer. Okay, let's write down here 1.3, right, grams per centimeter cube. All right. So how do we get your full 3 marks, right? Firstly, we put in the correct numbers into this equation. You should get your first mark. Okay. Over here, we should have your, oh dear, what happened here? All right, over here, we should have the correct number of significant figures. All right, that should be your second mark. And the third mark is the answer 1.3. Okay, doing this to get you your full 3 marks to fully answer this question. Okay. All right, so we are done with question number 1. Now, let me take a look at chat to see if there's any questions that are over there. Okay. Oh yes. So to Mr. Muhammad Umar Modi, yes. If you like to, you like to download the latest papers and download the answer sheet for this, you can go on to ciepapers.com. CIE Papers, right? To download the latest papers, and that's available over there. For this paper, the full answer sheet will be available for download after this session. Okay? Yeah. Okay, and as for Legend Yusra, okay, we cannot really do a prediction of what's going to happen, but we can best make sure you are prepared to take whatever is coming for you. Okay, so pretty much most papers, right, in IGCSEs, right, they do follow a formula, and it is very straightforward. So as long as you do much practice and you take your time to understand all the scientific, all the physical, all the physics. Not just memorize equations. You must learn how to use them. You must learn how to practice with them. And once you do more, if you practice more, you should be able to handle most of what Cambridge throws at you. No problem. Okay, right. So I hope this answers your question. Okay, yeah. Then without further ado, let's move on to question number 2. Let's go. All right, so this is a question for the cooling of hot water in a beaker, right? And pretty much this is once again, a very simple experiment that the student is doing, right? So as you can see over here, the apparatus shown is here, a thermometer and a beaker. And the thermometer is held on by this clamp system over here, right? So the student takes the thermometer, clamps it there, and do nothing. We are to measure the room temperature. And the room temperature, as you can see over here, is 22 degrees Celsius. So on figure 2.2 over here, which is this thing, this thermometer, right? We are to show where exactly is 22 degrees Celsius. What should the thermometer be reading? So let's take a look over here, right? Okay, so each of these big readings, right, is 5 degrees Celsius. Each of this small degree reading is 1 degree Celsius. So so very, very easily, 20, 21, 22. 22 degrees Celsius is here. Right, so let's just draw the mercury, not mercury, sorry. You guys don't use mercury thermometers anymore, right? You guys do alcohol already, right? Man, I'm old. Let's see, 22, right here. Should be right here, yeah. So you need to draw a line somewhere around here, okay? And then you need to shade, okay? Shade this whole thing. Basically, you need to shade this thing, this part, the bulb, which is where all the alcohol is, okay? And you need to shade this stem over here all the way up to 22, okay? So please do this as cleanly and as neatly as possible. Please don't do what I'm doing. This is a very negative example of what you should do in exams, okay? Shade this nicely, okay? Yeah. If you look at the answer booklet, the answer that I'll be giving out later and the PDF file, it should be much nicer, okay? It should not look like that, okay? And of course, if you show 22 degrees very clearly on the thermometer like this, you should get your first mark, okay? All right, let's move on. So let's move to question 2, part B. Now the student pours 100 centimeter cube of hot water into an empty beaker and she records the temperature theta of the hot water in the V equals to 100 centimeter cube row of table 2.1 as shown over here. Okay, so she records first the temperature of the hot water, okay? And then without delay, she pours 20 centimeter cube of cold water into the beaker. She stirs the water and measures the temperature of the mixture of hot and cold water. So she repeats the procedure until she has added a total of 100 cm cube of cold water into the beaker. So basically, you have the beaker of hot water, right, with the thermometer inside here like this. And our dear lady over here pours in, 20 milliliters of cold water at a time. So every time she pours in 20 milliliters of water, she mixes the water, hot and cold water together, takes the temperature reading, and continues with the next 20 milliliters of water. Okay? So all the readings, as you see over here, it starts at 100 and ends at 200. And theta over here starts at 87 and you see it gradually going downwards. So of course, the more cold water you add to the hot water, the cooler it gets, right? It gets cooler and cooler and cooler as you add more cold water into the system. Yeah? Alright. So now, everybody's favorite part, right? We want to draw a graph. Okay? So over here we are to plot a graph of temperature theta, which is the y-axis, against the total volume of water V, which is the x-axis, and you do not need to start the axis and origin 0, 0. So you take a look at this, right? You do not need to start the axis at origin 0, 0. And we are to draw the best fit curve. Take note, you can draw a curve, you don't really have to draw a straight line, okay? So now let's do what we usually do best, okay? Let's draw the axis over here, okay, for our graph. Let me just line up my ruler properly so it doesn't go anywhere. Okay, stay. Yeah. Oh dear. Oh dear, oh dear, oh dear. Wait a second. Delete, delete, delete. That is bad. Okay, then nice straight line. Please, technology, give me a nice straight line. Good. All right, so we have one arrow here and one arrow here. Okay, and we are to plot the graph of temperature theta, all right, on the y-axis. So theta comes here, okay? And of course, when you label the graph, you must also add the correct units for this. So the unit is degrees Celsius, right? Then over here on the x-axis, right, we have the volume of water, which is V, okay? V should also have its volume, its units, and since we know its volume and it's in centimeter cube, let's write cm cube. Okay. Now let's check out our data over here. We start at 100 and we end at 200. Okay. So let's take a look over here. We have 1, 2, 3, 4, 5, 6. So let's start at, let's say, wait, we have 100 over here, right? Okay, so let's start at 100 over here. We can do that. Okay, 120, 140, 160, 180, and 200. Okay, and over here we have 1, 2, 3, 4, 5, and 6 labels. Oops, the sixth one is horrible. Ah, yeah. Dang. Undo, undo, undo. Right. Sometimes please excuse my horrible drawing skills. Okay. So the temperature goes from 87 and goes down to 49. So let's say we can start at 90 over here. Then there's 80, 70. Oh, 80 should be a little bit lower like that. Yeah, should be a bit higher over here like this. Okay. And then 80, 70, 60 should be here actually. Okay. 50, 40. And then here is 30. Here is 80. Okay. Right. So if you look at how we had done just now, it looks like this, right? In a nice, if you do this nicely on a piece of paper, once again, please draw this properly on using a ruler, okay? This is very, very much needed, okay? So please draw this nicely like this. You should get the axis like that if you do it nicely, okay? Now, let's move on to start plotting each of these values, okay? So at 100 ml, right, the temperature is 87. So 100 at 100 ml, which is right here, okay, the temperature is 87 degrees Celsius. So each of these little boxes, right, one marking over here is 1 degree Celsius. So 90, 89, 88, 87, 87 to be right here, okay? Of course, please remember when you're doing your plotting of the graph, right, each of these little axes should be as small as possible and they should be very nicely defined, okay? So let's move on to the second one. This is 120, 73. 120 is right here. 73, okay, 70, 71, 72, 73, right here. Bam, right here, okay, 73. Next, 140, 65. 140 right here, 65 right bang on the center right here. So 65 is here. Okay, third point. 160, 59. 160, 59. 60 is here, 59 is right here. Okay, right here like that. And then 180, 54. 180, 50, 54, 55, 54 right here. Okay. And then last but not least, 249. 200 is right here. 50 is here. 49 is right here. Okay. Something like that. So you see, right, this graph this plot looks like this right now. So if you are to take a look at our sample over here, as you can see, right, nice downward slope, right? But the thing is, right, if you notice this downward slope, right, the gradient is not constant. In fact, right, you can see this is somewhat of a curve, right? So last but not least, we are to add a curve, right? We are to draw the best fit curve. So we can maybe start around here, and then we'll just make sure this thing is very nice and neat. Okay, this is a negative example. Please don't draw a curve like this. Use a what's the thing called? You have this, flexible ruler thing, right? If you have that, please use that and draw the curve properly. Okay, if you do so, you should be able to get something like this as a positive example. Okay, so please use your tools properly. Okay, yeah. Okay, so once you get something like this, okay, right? So once you get something like this, you should be able to get your full 4 marks. So how do we get the full 4 marks? So the first mark is given to you when you draw the axes correctly, label them correctly, and place them correctly. Okay, that's the first mark. The second mark is given for a suitable scale and correctly plotted points. So all these little numbers right here gets you your second mark. Okay, and your third mark is given when you draw the plots correctly and within half a small square. And finally, the last mark is given for a nice thin continuous line of good judgment. Mine definitely doesn't make it, okay? But please refer to the diagrams when you actually get it, all right? Okay? So, and if you are drawing the curve, please bring a ruler or please draw it using the flexible curve, okay? The flexible ruler for your graph drawing, okay? Right, so with that, we are done with question part C. And let's move on to part D. Right, so part D, in this experiment, the student aims to investigate the effect on the temperature of the hot water when cold water is added. And we are to complete the sentence to explain why is it important to add a cold water without delay at this stage, right? So as we said before, the hot water is here. They take the cold water, pour it without delay, and mix it ASAP, right? Why do they do that? Why do you want to add the cold water immediately? Right? Because if you leave the hot water out like this, right, the heat will dissipate, right? The heat will be passed on to the surrounding, and your reading will not be very accurate anymore. So the cold water is added without delay, right? Okay, to prevent heat loss. Okay, any heat loss, right, from the hot water, right, to the surroundings. Okay, so by doing so, if you write down that it is to prevent any heat loss from the hot water to the surrounding, immediately you get your 1 mark. Okay, and the second part, right, we are to complete this sentence again. The student stirs the water before recording the temperature. Why we do that? Because when you pour the cold water inside, right, one part of the water can be hot, one part of the water is cold, and they are not mixed together well enough. So, in order to make sure the water is even in temperature, we stir the water properly before you measure the temperature, okay? So, the student stirs the water before recording the temperature, right? To ensure, right? To ensure that the temperature, okay, throughout the liquid, right, is even. And just by writing that, your next 1 mark in your bag. Okay? So very straightforward, right? I mean, a lot of these things, if you think about it, is just pretty much common sense. But it is all the things you have learned from heat, from dissipation, from conduction, convection, radiation, all these things that you have learned in the syllabus, now you're being applied into your questions, all right? So do take note, Cambridge is not exactly a paper that you can just so-called mark, memorize everything and regurgitate in the exam hall. You have to use all the information you have and try to solve problems with it, okay? So with that said and done, okay, let's move on to part E, okay, for our question. Question number 2, still question number 2, right? So we are to suggest 2 methods to reduce the loss of heat or thermal energy, in this case, from the beaker during the experiment. So, as you can see, right, just now we have a thermometer stuck right here, and then we just pour water inside like this, okay? So, what is the best way to prevent heat from escaping into the surroundings? Simply, you can wrap the whole beaker in some sort of insulating material, right? That's the first thing you think of. We can put it in some sort of, towel or something to prevent heat from escaping, or you can wrap the whole thing in tin foil so the heat is reflected back in, so on and so forth, right? Some form of insulation is great. So let's write that down. Okay, we can wrap insulation. Oops, my handwriting is horrible today for some reason. Wrap insulation, all right, around the beaker. All right, to reduce heat loss. Right, to surroundings. Okay, that's the first method. Now we have a second method. Okay, so your beaker over here, right? The other option is, if you want something to remain warm for a long time, right, or cold for a long time, you just take a cap and just cover it, right? So it will stay warm for longer because heat doesn't evaporate, the water doesn't evaporate and cool the water inside, right? So the other option is to use a lid. Okay, yeah, use a lid to cover the beaker to reduce heat loss via the top of the beaker. I'm not going to write that down. You can take a look at our answer. And of course, if you can write any other answers, such as, for any form of insulation, adding a lid, shielding from, let's say, from wind, and using a white and shiny surface inside the beaker or around the beaker to reflect the heat back into the beaker, you should be able to get your 1 mark each, okay, to get your full 2 marks for this question. All right, so with that said and done, finally, we are to name the apparatus that a student used to measure the volume of water when you pour the cold water inside. So what's the apparatus that a student can use? Of course, anything that is used to measure volume of water more accurately is something called a measuring cylinder, right? This long thing that you see in the lab, right? And you have all the graduations right here. Okay, so this is the most accurate way of measuring liquids. If you use a beaker, then the beaker is not exactly very accurate in measuring liquids because there's only one graduation. Like, let's say this is 50 ml, right? So most people, most experiments, they will use measuring cylinders to measure volume. Okay, right? So with that, 1 mark, and we are done with question number 2. So once again, I'm going to throw a question to the floor. Have you guys have any questions and queries for us? Let me take a look at the chat section, okay? So far so good, no questions. All right, then let's move on. And to Mr. Muhammad, I hope your answer has been answered by Narayan sir. Okay, let's move on. All right, so this is a drawing question, okay? Number 3. So for this question, please take note, right? If you don't, print this full scale, and if you don't use a ruler, you are bound to not get this correct. So once again, for those of you guys who are joining us for this session, please print this paper out on A4 paper on full scale, and try to try to make sure, right, to draw everything using a ruler and a pencil. Okay, a pencil is easier to erase, so you can make corrections to it if needed to be. All right, so let's move on to question number 3. 1 second, let me get a sip of water. Okay, so question 3. So a ray trace sheet is shown in figure 3.1, like that. Okay, so now let's go to part A. Part A wants you to draw a normal to the line MR that passes through the center of MR, and we have to label the normal NL. Okay? So, MR is over here. We need to first measure how long MR is. Okay? In this case, what you can do is you measure how long MR is and then select the center over here like this. Okay? Just mark a center over here. Then you take your protractor, okay, and put the center point at over here, and then make sure over here this is 90 degrees. Okay, once that is done, you should be able to draw a nice long line, right? That is the normal okay, like this, okay, and then we have to name this N, R. This is our normal, okay? Okay, label at the point at which NL crosses MR with the letter B. B is here, okay? Alright, so B is the mark over here. Next, we are to draw a line 10 cm long from B at an angle of incidence of I equals to 40 to the normal below MR and to the left of the normal, and label this end of the line A. Okay, so it has a 10 cm line from B at an angle of incidence 40 degrees. What does that mean? So this is the normal, right? So we are to measure 40 degrees from the normal. So let's put our protractor once again like this, okay? At this is where the center is, all right? Please ignore the fact that my protractor is a little bit off here. So 90 is here, right? So if you want to measure 40 degrees over here, okay, so this should be 90 minus 40, which is the 50 degree mark here. So let's draw the line over here properly, okay? Something like this, okay? All right, so my line is not accurate, but please do this properly, all right? Okay, this is 40 degrees. Okay, and make sure this line over here, right, A to B, right, is 10 centimeters across, okay? So it's a 10 cm line from B, okay? So from here to here, this must be actually 10 centimeters, okay? If it's not 10 centimeters, you will be penalized. Oh, you will not be given a mark if you draw a line that's shorter or longer than it, all right? So, of course, if you do this properly, right? Give me a second. Okay, you are given 1 mark for the correct normal, which is 90 degrees, okay, over here. And then the second mark is given to you if you draw a 40-degree line like this, okay, left, right here, and it has to be properly 10 cm, okay. Doing so should be able to get you your full 2 marks for part A, all right. And let me show you a correct example. So step 1, you get this. Of course, you get your normal 90 degrees right in the center. And step 2, you draw a 40 degree line and down like this, 10 centimeters across. Mark this A, okay? Yeah, make sure this is 40 degrees and make sure this line AB is 10 cm, exactly using a ruler, okay? Once again, I have done this on a computer screen with a ruler measuring the computer screen. So this is accurate, okay? Now let's move on to question 3b, okay? Question 3b, right? The student places the reflecting surface of a mirror vertically on line MR, okay? Okay, reflecting face of a mirror vertically on the line MR. So the mirror is like this right now, okay? All right, it's right there, right at MR over here. So let me just do this easier. Okay, there we go. That's better. All right. So he places 2 pins P1 and P2 on AB. So we are to mark the positions P1 and P2 with crosses X on the line AB, a suitable distance apart for this type of ray trace diagram. And we are to label the positions of P1 and P2. So basically for this sort of experiment, right, the 2 points that you want to measure from, right, you want to make it as far away from each other as possible. So let's say point number 1 is here and point number 2 is very close to A over here. Okay, so let's call this P1 and let's call this P2. Okay, so now that is done, we should get our 1 mark. Right, our the marking scheme does say that, right, you are given 1 mark for this question if P1 and P2 are over 5 centimeters apart. Okay, doing so will get you your 1 mark. So far so good, right? Okay, so let's move to part C. All right, so the student views the images of pins P1 and P2 from the direction indicated by the eye in figure 3.1. So looks around this area, okay? Not here, but around this area, okay? Now, he places the two pins P3 and P4, so that's pins P3 and P4 and the images of P2 and P1 all appear exactly one behind the other. So the positions P3 and P4 are shown in figure 3.1 over here, okay? Now we are to draw a line through the positions P3 and P4 and continue until the line meets MR over here. So let's draw a line between P3 and P4. Okay, this is no business of being this good, but there we go. Okay, this is line done. Okay, and we are to measure the acute angle alpha between this line and the horizontal line MR. Okay, and acute angle is angle less than 90 degrees. Acute angle A alpha between this line and horizontal line MR. So we have to measure alpha. Okay. Oh. All right. So we have to measure this over here. This is alpha. I have made a mistake. Oops. All right. So let me show you. All right. So when you draw a line P3 and P4, okay, and then we are to measure, okay, this acute angle between this line and horizontal line MR. So this is wrong. I'm sorry. This is a bit silly. So alpha is supposed to be here instead. Okay. So please take note of that. All right. So let's measure alpha. Okay. All right. Over here, I've done the measurements and alpha should be 48 degrees. Okay. All right. So as long as you measure the angle to be 48 degrees plus minus 2 degrees, you're fine. Okay. All right. So let's move on with this question. Okay. The student turns the mirror through 180 degrees. What does that mean? So he takes the mirror, which was originally on top here, and move it downwards here, which is now this diagram. This is the mirror, okay? MR, this is the mirror right now, okay? This area, okay? Right, so okay. He now draws a new incident ray at an angle of incidence I equals to 50 to the normal above MR and to the left of the normal. So he draws a new incident ray at incidence I equals to 50 here, left side. So this should be about like this, okay? This should be 50 degrees, okay? Oops. All right. And he labels the end of this line C. This line is not shown in figure 3.1. You may draw the line on figure 3.1. Of course, I will draw the line. This is C, okay? This point is C. Right. He places the two pins on the line CB and views the image of the two pins from the top right-hand corner of the ray trace sheet. All right, so on figure 3.1, draw the reflected ray 10 cm long from B with an angle of reflection beta equal to the angle of incidence and label the end of this line D. Okay? So we are to draw another line like here, right? That is 10 cm long, okay? And is also 50 degrees as well, okay? This is also 50 degrees and this should be beta. And once this is 10 cm, and this should be D, okay? All right, So as you know over here, because we are doing this, beta is also equals to 50 degrees, okay? Now, after we draw this, right, we are to suggest a relationship between the angles alpha and beta, okay? And we have to justify the answer by reference to the results, okay? Okay, 1 second. Okay, we have to suggest a relationship between alpha and beta and justify the answer by reference to the results, okay? So, as you can see over here, alpha is over here, beta is over here, all right? So, since this, right, is alpha and beta, right, they are very, very close to each other. Alpha is 48 degrees over here, beta over here is 50, right? We can suggest, right, alpha and beta are experimentally equal to each other because, you see, alpha is equals to 48 degrees, beta is equals to 50 degrees. So they are within 10% of each other. And if that's the case, right, alpha and beta are equal. So let's write that down, okay? So let's write down alpha and beta, right, are experimentally equal to each other. Okay? That's your first mark. Because justification. Why is that so? This is because right? This is because both angles, right, are within the limits of experimental error, or in this case, which is 10%. Okay? Right? So if you know 10% of 48 is 4.8, 10% of 50 is 5.0. So 48 and 50, the difference is 2, which is well within the 10% error rating, right? So once that is done, you should get your full 2 marks, right? One is the relationship. You just need to write something that is sensible. And number 2, you need to justify your relationship and your justification, okay? And of course, when you finish drawing everything over here, right, you should get something like this. This should be alpha instead, okay? Sorry for the error. I will redo this for you guys, all right? So, next, part F. We are to suggest 2 techniques to use in this experiment to obtain a very accurate ray trace. So, 2 marks, right, for 2 valid points. How do we do so? Number 1, we do know that if you are doing a ray trace, you need a sharp, well-defined line, right? To do that, you need a nice sharp pencil to draw that line. So firstly, let's write that down. A thin sharp line is required. A thin sharp line, okay, drawn with a sharp pencil. All right, should be used for an accurate ray trace. Okay, and number 2, if your pin, right, that you use for P1, P2, P3, and P4, right, if your pin that you use over here is so fat, right, you don't know is it this part or this part you're looking at. So in contrast, you want a very thin and very precise pin, right? Sorry, this is not a very good idea. This is much better. Instead of doing a pin like this, you want some pin that looks something like this, nice and thin. Tack it right in there. So with a very thin pin, you can easily, see exactly where you need to be. So use a thin pin like this. Thin pins should be used, right, to accurately determine the 2 points. Right? So writing these two down should get your full 2 marks. And what are the other answers you can write? For example, you have to make sure your pins, right, must be pinned down, right, vertically to be as accurate as you can, and your pins can be roughly 5 cm apart for or more for much better distance, easier to determine your line. Okay, once that's done, let's move on to part 4. But before that, any other questions so far in the comment section? Looking good, actually. With that done, let's move on to question number 4. Okay, question number 4, we are to plan the experiment. This is everybody's favorite. We have to write a lot, right? So not my favorite, but I guess this is quite straightforward for me. So thank you, Naransa. There's no questions on your end as well. Fantastic. Let's start at question 4. All right. So for this question, right, the student, right, investigates the relationship between the diameter, right, and resistance of wires. Oh, so he's trying to find whether the diameter of a wire affects the resistance of wire. Of course, we do know from our textbooks, from our lessons, that the thicker the wire, the bigger the diameter of a wire, the lower the resistance, right? So over here, the apparatus are available. So we have wires with different diameters. We have an instrument for measuring the diameter of the wire, which is basically the vernier caliper, right? Or a micrometer, screw gauge. Right? So one of these two will work. Okay? And then we have a meter rule, an ammeter, right? An ammeter, a voltmeter, and a power supply. Okay? We don't know what's the power of it yet. So, of course, other apparatus are given as well. You are to, state, right, what are the additional apparatus you need. So, we are to plan an experiment to investigate how the diameter of a wire affects its resistance. Okay? Of course, you're also given R equals to V over I, right? The equation, Ohm's law, where V is the potential difference across the wire and I is the current going through the wire. So in this plan, right, we are to draw, number 1, draw a circuit diagram to show the circuit you use. And number 2, you are to explain how you do this investigation. Number 3, you state one key variable to keep constant. And number 4, you draw tables with column headings and with the correct column heading units, right, to display the readings. Okay. Of course, you don't need to write any readings in there. And last but not least, you have to explain how you use your results to reach a conclusion. So, very simple. Let's start with the circuit diagram, right? Okay. So, you have a power source, right? Plus, minus. We definitely need a switch to be a bit safer, right? And then we connect an ammeter directly in series with the wire, which is right here. Give me a second. Okay, this is the wire over here. This is the length of the wire okay? And then, of course, you have to connect a voltmeter to check the voltage reading over here, all right? You have to check the potential difference across the wire, okay? So this is our circuit diagram, very straightforward. Now let's move on to how we actually do the experiment. So first things first, since we know, right, we are investigating the diameter of the wire and how it affects its resistance. So we should actually keep one thing constant, which is the length of each wire. So let's say you can have, let's say, a wire that is maybe this thick, right? And we have another wire that is this thick. So they have to be at the same length, right? To be very to be fair for this competition, for this not competition, I call it. It should be the same length for this whole experiment, right? So the one variable to be kept constant should be the length of wire, right? Okay. Some other things you want to also, keep constant is also the material of the wire. So I mean, it won't be a fair comparison if you, let's say, wire A, which is thicker, is made of copper, wire B is made of silver, wire C is made of gold. It scrambles the entire experiment, right? So please take note of that. All right. So the next thing you want to keep constant is also the potential difference across this whole experiment, right? Because it is nicer if let's say this is 12 volts and we keep it that way. So every single wire is given 12 volts and you don't really have to change the voltmeter reading at all. All right. So first, let's write down our first point for this experiment, which is what are we going to keep constant? So right here, right, for this experiment, since we are investigating how the diameter of the wire affects its resistance, the length and material of the wire should be kept constant, and the potential difference delivered to the power supply should also be constant for, for simplicity, right? Okay, now we know what we need to measure, what we need to keep constant. We need to measure, whoops, right, it has to come here. We need to measure the diameter of the wire, right? So either using a vernier caliper or you can use a micrometer screw gauge. All right. So we measure the diameter of the wire using a micrometer screw gauge, and then we can connect the wire to the circuit as shown, basically to check the voltage and the current of the going through the wire. Okay, just do this nicely. Ooh, right here. Right, that's really nicer. Yeah, that's much nicer. Okay, so using the values of wires of voltage and current, we can calculate the resistance of the length of wire. So as we have seen before, the resistance, right, R is equals to V over I, right? So now that's done. So the first wire is done, right? But the thing is, we can't just do the experiment for one wire. We want to do it for several wires of different diameters. So what we do is we repeat the experiment for the same length of wire, but they are of different diameters. Okay? We shall repeat this experiment for at least 4 to 5 more wires. Okay? Let's write that down. There we go. Okay? Right, so we repeat the experiment using the same length of wire but different diameters using the micrometer screw gauge, okay? And we now record all these data into a table. But before that, let's draw the table like that, okay? So we should have different number wires. So let's say one is wire number, okay? This is the first one. Let's say 1, 2, 3, 4, 5. They have 5 wires, okay? Then we have the diameter D, which is in millimeters, okay? We have the voltage, which potential difference, which is in volts, right? We have the current, which is in amperes, and finally, by using R equals to V over I, we have the resistance, which is in ohms, okay? So by doing that, we should have a very nice table to record your values in, okay? Now, with this data collected, okay, right? Now let's do this, okay, table. With the data now collected in the table, we can now draw a graph of resistance versus diameter, right? So the graph should be like this, okay? So it should be like this. So resistance and diameter. So the diameter is over here, diameter in, I think probably in millimeters, okay? And the resistance in ohms, right? So it's expected, right, that due to what you have learned before, we expect, right, thicker wire, basically as D increases, resistance should decrease like this, okay? So we should get something like that, all right? Okay, so this question is worth 7 marks. So how are we going to get the full 7 marks? Okay, so first mark is given for this, a good circuit diagram. That's your first mark, all right? 1 mark is given for measurements made of the diameter of wire, okay? Voltage and current of circuit when connected. We have written it over here. 1 mark is given if you calculate the resistance of wire using this, R equals to V over I, okay? 1 mark is also awarded for repeating this experiment with at least 2 other diameters of wire, all right? And 1 mark is given for one variable to be kept constant, which we have written length of wire and material of wire, right? 1 mark is awarded for a drawn table over here, right, of basically the wire number, the diameters of each wire, the potential difference, the current, and the resistance of each wire. And 1 mark is given finally for a proper conclusion of basically you plot a graph of resistance against diameter, or you compare the values of diameter and resistance in the table and you draw a conclusion from that, okay? Doing so, all of these things will give you your full 7 marks. So basically, if you are wondering how to score all these sort of things, how do you answer these, right? We have an answer sheet that's coming out soon after this video is released, okay? So once that's done, we are done with our paper today, right? So very good, we are done for today. So let me check if you have any other questions from the chat. Okay, looking good. Looks like there's no questions. And with that, we are done for today's paper. Fantastic. Right, so let me just go back to this and let me go back to this. All right, so let's quickly wrap up everything for today. So once again, for all of you who are watching live, thank you all for joining us. Right, thank you for joining us for this paper solving session. For those who have solved this paper together, I hope this video helped you to, see the methods and tricks that are used to solve these questions, and this help you to solve more papers like this in the future. Now, before we finish up everything, I would like to mention our so-called sponsor for today, Homeschool.Asia, which is the website that brought you this video. So if you want the best experience for studying for the Cambridge syllabus for IGCSE and A-levels, please head on over there, Homeschool.Asia, all right? So we offer several subjects for IGCSEs, mainly physics, mathematics, biology, and chemistry. And as for the A levels, we have all the subjects as mentioned, plus accounting and economics. Each subject has over 100 videos teaching you individual topics in detail, including how to solve difficult questions in past year papers, and as well a mountain of resources to basically, for example, self-generated test papers and revision notes. And all this should be able to get you, should be, the materials that will help you to get that A in the subject. So as for this paper, I've downloaded it off ciepastpapers.com, where all the latest past year papers from Cambridge are available for free. So do visit there to download more papers for your reference and practice. So today's paper will also be made later available for download. All the answers that I've been giving you, we will be presenting everything in a nice PDF file for your download. Okay, so do go ahead and click on all the links below. All right, and finally, I'd like to thank all our staff. Narayan sir, thank you for joining me once again, and thank you for the Homeschool.Asia team for making this another successful stream. So once again, wishing everybody here good night, evening, good afternoon, morning, wherever you are, and all the best for your examinations. See you in the next video. Bye-bye.